just out of interest, who was here for the first React talk this morning? Okay, so at least half, about half. As another kind of gauge, who here has used React already as well? Okay, so slightly less, luckily. So this is actually the second time that I've agreed to give a talk on React, only to find out after agreeing to it that someone from Facebook or Instagram was going to speak about React before. So that certainly makes it kind of interesting in terms of gauging quite how much React content I should talk about. So there's going to be quite a bit about the kind of isomorphic aspect here. Now, before I kind of get into some of the details, I just want to kind of start off by saying that unlike a bit over a decade ago when I started building web apps, just like the kind of keynote speaker with Java J2E, the front end was actually particularly kind of boring. And I think if you kind of look at the landscape today, we've got a kind of a new browser war going on, and the performance is quite astonishing, really, especially if you look at the progress that's been made, particularly over the kind of last 5+ years. So this is a snapshot from the recent kind of Google I/O, where they're kind of talking about kind of more improvements on the kind of V8 engine, and particularly exciting, I think, for any of us who are having to kind of deal with the mobile web. They're clearly taking V8 on Android OS very seriously. I think another kind of tip of the hat needs to be to kind of Mozilla with their Asm.js. And this ability to kind of compile raw C and C++ down to kind of near native speeds. I mean, technically, I'm still kind of a bit amazed that that's even possible in a browser. I think it's also kind of fair to sort of point out that Safari and particularly on kind of iOS has been kind of great. It is obviously the kind of foundation that kind of Chrome built itself off. Even if some of their kind of press that they put out feels a little bit kind of skeptical when they're talking about kind of performance, it certainly has seen like continual kind of improvements every year. Finally, I think it's also kind of great to point at kind of IE, and although it may have kind of missed out on the mobile OS wars, at least they are kind of trying on the kind of desktop, and kind of IE11 is certainly kind of a big step forwards from what it was before. So if we're seeing all these big performance improvements in browsers, why are websites getting slower? So there's this study that Radware and Level 3 publish every quarter, and the trend is kind of worrying. So I've worked at a number of startups, particularly over the last kind of 4 years, and they often talk about graphs needing to be up and to the right. But I hope we all kind of agree that this is definitely the wrong kind of up and to the right. So if you start to kind of drill into what's causing some of these issues, then it's kind of clear that over the last 3 years, if you look at kind of HTTP archives kind of data, we're over doubling the amount of information that we're shoving down the pipe to the browser. And it's pretty consistent from the kind of CSS to the imagery to JavaScript. Another thing to kind of point out is that actually things have got quite a bit harder. Although kind of 3 and 4G are high in kind of bandwidth, they actually have an awful lot of latency kind of built in. But I think another thing that's kind of worth calling out is this rise of the single page app. So again, kind of when I started doing kind of commercial web apps, all the interesting stuff was on the kind of server side. If you're doing too much stuff on the client, you were probably doing it wrong. If we look at the landscape today, I think it's kind of fair to say that an awful lot of the kind of more interesting advanced apps are largely kind of being driven by the clients, and specifically with JavaScript. And I mean, I think actually this is kind of great. They are more native-like if you go kind of a bit deeper than just shoving in kind of Bootstrap. They also do have very quick kind of next load times if you've got an API that's kind of quick enough for that. If you're willing to work with the app cache being a douchebag, then you can also kind of build transient on offline apps. And I think the other kind of really, really important thing is that with us focusing on kind of one language, namely kind of JavaScript, they become kind of much more friendly for kind of front-end developers to build. Having said that, I mean, as the numbers I kind of showed before, they are getting slower. So I suppose the kind of real question, the thing that kind of troubles me is how slow is too slow? And I kind of came across what I think is quite a good example of this recently. So at the moment, I'm trying to bootstrap a new startup, and I'm doing a bit of consultancy for a large kind of corporate that's working with a legacy Angular.js app. Now, I kind of experienced this recently whilst tethered to a 3G connection. So I know this isn't necessarily completely fair, but hopefully this does give you some idea about how painful some of these experiences are when they're actually being used in the wild and not on our kind of local development machines. So what I've done here is I've recorded the browser. In the top right-hand corner, you'll see the time kind of ticking along in sync with the video. And below the timeline here, you should see the resources that you hopefully are used to from things like the Chrome Inspector. Now, as I let this run, and I just kind of pause here, you'll notice that nothing has changed on the screen. So this is kind of a good 5.5 seconds in. If I scroll down, we can actually see the HTML page. I think pretty much all its CSS has already loaded. What we're waiting for at this point is one large JavaScript file. So if I continue to play, again, we have to wait for another kind of painful sort of 5 seconds, a few more things load. So at about kind of 10 seconds in, we finally see this document kind of ready event being fired. And it's at that point that Angular is starting to kick in. It renders the small little bit that it can on the left before then going on and continuing to kind of request the rest of the content. Now, again, obviously kind of on a fast developer connection, this is probably like fairly unlikely, but I would sort of question how many of your users, if you're building apps, particularly with things like Angular, do run this painfully over a kind of 3G connection. Okay, so perhaps there's another way of building these apps. And it's actually to kind of try and pull some of that, particularly the first page logic, back into a shared space that both the server and the client can render. Now, luckily, Airbnb coins the very hipster term isomorphic, which was really about this kind of idea of these kind of client and server apps. Now, I do need to kind of just go on a slight aside. That naming things is clearly one of computer science hardest problems. And some of you may have seen this comment to that post on Hacker News. So if you're coming in contact with anyone who's particularly kind of mathematical, then you might not want to use this term too broadly. Okay, so I think it was a couple of weeks after this Airbnb post, Facebook and Instagram open sourced a framework they've been using for a number of years, or for a couple of years building internally within Facebook. And specifically, it's a library that's focused on the user interface, and what that kind of breaks down to is a concept of components and a virtual DOM. There is a third piece, and I need to kind of put this in kind of brackets, that this really is optional, and we'll see kind of in a moment that, that this really can be optional if you hate the idea of embedding XML within your JavaScript. Okay, so I tend to work quite a bit with just looking at code, so I just wanted to kind of step through some basic concepts within React with code. So this is perhaps kind of the most simple type of React component. We can see that it looks a little bit kind of like creating a class. The key thing is the render function there that outputs well, in this case, it's kind of a div and an h2 tag with hard-coded kind of attributes. In this case, it's kind of my name and hello powered by JavaScript. Now, if we wanted to render this into the DOM, couldn't really be much more simple. We just add in this render component. We supply this comment React class that we've created, and then the element we want to kind of inject it into. So, okay, that was kind of boring. So let's actually allow us to kind of reuse this. So in this case, we've introduced the concept of properties. So both the kind of author and child props here that we're then going to configure from the parent. So you can see the kind of line on the bottom. I'm now kind of injecting in that name in there. So if you wanted to use this to build components that contain other components, then this would be kind of a simple way in which, in this case, we've created a conversation that can have many different comments in there. And we can see that we can very easily start using functions like map to convert these JSON kind of blobs into these other widgets, and very conveniently and easily kind of build up kind of complex user interfaces. Now, I mentioned JSX earlier, and I mentioned this is kind of optional. So this is like often the kind of recommended way that you'll see kind of Facebook sort of talk about this. And in terms of kind of changes to the code, we've obviously got the kind of XML tags embedded in there. And then importantly, the JS doc comment at the top to indicate to preprocessors that this would need to be compiled into the previous JavaScript format that we saw before. Now, I mentioned it's optional. So for example, this would be another way of doing it with just pure ES6. So again, I mean, you can see the syntax is actually pretty similar, rather, well, similarly kind of concise. Obviously, kind of if you're more kind of partial to kind of CoffeeScript, then again, we can take advantage of this kind of underlying JavaScript API to again create a succinct definition of our components. And then there's also the kind of things like the awesome OHM framework for ClojureScript that will also kind of deal with other things like state as well. Okay, so if we go back to kind of more kind of vanilla React, this is an example of introducing simple event handling. Now, in this case, we're simply adding something on the onSubmit browser action that should call this handle submit function. Now, one of the things which I particularly like about building UI or user interfaces with React is they handle things like the scoping of this very neatly. So in this case, although we kind of defined this.handle submit, we could have passed in any function there if we wanted to. This will scope that properly for you. Now, I mentioned kind of earlier a concept of properties which are kind of pushed in from parents. There are obviously occasions when actually a component needs to change its state. So in this case, we're actually having passed in a function into that comment form that will take the kind of author's name and text and submit that as a kind of post action to, in this case, a kind of API for conversations. Now, if we kind of look at the kind of second to last line, we can see the set states where we're actually replacing the whole conversation comments. And we'll see in a moment how React kind of deals with that kind of in a very nice way. Finally, because of this kind of approach and this concept of pushing properties down into kind of child components as well as state and encouraging you to re-render this every time, It also allows for very simple optimizations like optimistically rendering. So in this case, what we're actually doing is as soon as we get a new comment that's being created, we immediately push that to the end of the comments, re-render the page, then submit the form, and then once the whole conversation has come back, we can then re-render. So all of this is made possible with the very clever virtual DOM. So if we try and kind of model the simple example that we were working with before, the most simple case, if we're just adding on or appending a comment, I suppose if we were to do this with kind of jQuery, would simply be to use a jQuery expression to find the conversation and then append it to the end. Instead, what React does is, again, kind of force you to push an awful lot of this state down from parent components, and then builds up a render loop of changes, both for appending items but also removing them. So, for example, this could be the changes of posting a comment, then getting an additional comment from someone else, and perhaps someone's also actually decided to delete a comment. So all of that is completely taken care of for you. And a lot of this is all made possible thanks to these React IDs that it kind of spews across your DOM elements. Now, it's perhaps kind of a bit too much to go into that in detail now, but the key thing with these IDs is that React is very quickly able to identify which parts or which kind of children will need to be updated or can potentially be left untouched, making this algorithm very, very quick. Okay, so this is also talk about kind of building isomorphic web apps. Hopefully, it's been made kind of clear that React will deal very neatly with the changes between different DOM states. But how do we get that into the page in the first instance? Again, it couldn't be kind of too much simpler. We just simply, on the kind of server side rendering of this JavaScript, replace it with this render component to string. Now, there is one kind of key thing which I've sort of missed out, and that's that React is really about the kind of user interface. What it doesn't solve is both the kind of routing that you would need to do on the kind of client and server, as well as getting those kind of resources there. So there's a number of different solutions that you can use for this. Again, the startup that we're kind of bootstrapping, we believe that we need kind of a new DSL for that. So we've been developing something that feels like JavaScript, but got less of the, it's designed with kind of performance in mind. Okay, so I sort of hacked together a bit of a demo to try and kind of reinforce the kind of improvements in speed here. So we thought it might be kind of fun to pick on some of the fastest e-commerce websites out of the kind of level 3 study. So these are the only sites that we're loading with under kind of 3 seconds. Obviously, we can see kind of Amazon there, so we thought it might be fun to pick on the one that's kind of slightly faster than Amazon. So we threw together this thing called Mr. Portly. Now, I'm not sure whether people have kind of seen this before, but the new Canary release of Chrome allows you to kind of throttle down the connection. And I've sort of just jumped into that to try and give you kind of a bit of a better idea about what's happening with kind of loading. So as I say, this is kind of a bit sort of a hacked together store, but we can hopefully see that as we sort of click around, the page loads pretty quickly. If I refresh, it kind of loads in that state. So for example, if you wanted to have a look at the kind of HTML that's sent over, so in this case, I'm loading kind of an overview page, and we can see all of the kind of IDs and attributes kind of rendered out correctly in place. If if I was to go back to the front page, reload view page source, we can see this has got all the HTML for the first page. Now, I suppose a number of you are probably kind of wondering sort of why bother. So again, I tried to kind of record another video late last night of this loading over a simulated 3G connection. So again, we got the clock in the top right-hand corner and the resources loading in from the bottom. So I'm just going to kind of pause there at kind of 1.5 seconds and scroll up again. So you'll kind of notice, if I scroll back, that our change to, well, in this case, a fairly kind of blank page, and I'll touch on that kind of in a moment, has been much, much quicker this time. And the reason for that is, as we can see, this kind of blue line here, from the browser's perspective, it's got what it thinks is enough to start rendering the page. So in this case, yeah, it's got enough of the kind of CSS file, and it's starting to kind of download the images. Now you'll notice that the JavaScript hasn't finished downloading at this point. It's a full, yeah, so sort of almost 4 seconds before that's actually managed to download. But in the kind of meantime, because the browser has basically got everything that it needs, it's been kind of more than happy to go away and actually start rendering the experience. Obviously, if I kind of let it play, then it's at this point that then we've got the kind of full experience kind of loaded. Now, again, I kind of just want to reinforce this is over a kind of a 3G connection. Obviously, a lot of people will be accessing it on kind of faster connections. But hopefully you get kind of a flavor of how much quicker that can be. So we did a kind of speed test on this with web page test. So this is an example of it comparing to the parent site of where some of the content came from. So you can see quite a big kind of improvement here. Now, when you start kind of throwing away this idea that you either are kind of clicking through different pages that either kind of needs to link, needs to load each time. You need to kind of emulate typical kind of browser behavior in order to kind of ensure that users know that something is going on. So you may have noticed there was kind of a bar across the top kind of loading, even though the page wasn't actually loading. So I think kind of YouTube was one of the first to kind of do this. You also, I'm sure many of you have gone on kind of Medium and seen that kind of same sort of page loading. But there was kind of another technique that was also used in order to kind of make this quite so fast. So this is what I like to refer to as the kind of on-ready anti pattern that is very popular, particularly with kind of jQuery websites. So instead of waiting for effectively the kind of blue line, what we're able to do is a technique that's very similar to Google Analytics, where we asynchronously load the JavaScript as kind of early as possible. And then in order to actually start the app, we kind of push it onto an array that may or may not have already been created. And it's at that point, particularly if you're using things like Speedy or you're using kind of proper caching, then there's a very good chance that the JavaScript may execute the instant it gets to that start point. If not, then it's as soon as the JavaScript is kind of loaded and parsed that it can start executing. Okay, so summing up, browsers are faster than they've ever been, and it looks like they're going to continue to get quicker. I suppose my only kind of plea for us developers is not to waste that performance. One of the kind of ways in which we can address that, that performance gap is through an isomorphic kind of client-server sort of approach. And we get the kind of benefit that we can reuse far more code. I haven't touched on SEO at all, but we kind of get that out the box. And then, yeah, obviously the kind of performance is noticeably better. To the point where I actually believe that these sorts of apps can actually be better than native. If you imagine that kind of a well-optimized web app that uses this sort of approach can effectively install itself and start delivering an experience within a second, even under the kind of most brutal kind of connections. If you replace that with having to go through the App Store, there really is, as I believe, kind of a great kind of opportunity here. And then I suppose kind of finally, React, having played and worked with kind of a number of different libraries trying to build kind of isomorphic web apps, React is by far the kind of simplest and sort of more enjoyable. And that's in addition to kind of all the other kind of benefits of it being kind of much more modular, easier to test, and I suppose in vogue at the moment. So that's it. Thanks.
So it looked like you were using, when you were doing the rendering on the page, do you need to be using a JavaScript server, like something like Node on the back end in order to pre-render?
So that's definitely a very, sorry, the question was with regards to how do you render kind of on the server side for the kind of first request. So if you're using React, then yeah, it needs to have some JavaScript kind of interpreter on there. So kind of Node would obviously be the really popular one nowadays. I think the stuff that they're doing on the JVM is really interesting if you want to kind of plug it in to, I suppose, a bigger, more complex app there. In our case with Cohesive.io, we've embedded V8 into a completely custom web server. So you definitely don't have to use Node, but yeah, if you want to use React, then it's written in JavaScript, so you need something in JavaScript to interpret it.
Okay. I thought maybe you could do like a, I don't know, call out to some library that interfaces with JavaScript. We aren't using anything JavaScript based on the server side right now.
So yeah, your kind of question was whether you could call out to some other service to render it. So from what I understand, Instagram, when this first was launched, did exactly that. They're a kind of Python shop. And yeah, so they were initially doing kind of server-side rendering by sending that off to some other service that rendered it. But from what I understood, the person who built that left that team, and then they wanted to support it, which is why I think right now Instagram doesn't do isomorphic kind of rendering. It's just rendered after the page is loaded. But yes, yeah, you can definitely call off to a third-party service if you want to.
Don't worry, we're bringing it back.
Okay.
Because I work it.
Any more questions?
So, are you doing server-side rendering and then working with the logic on the front side? And if so, how do you get the state from the server side?
So I think the question was, so
for example, the demo that you did, were you rendering it first on the server side?
Yes.
So,
Yeah.
like if there's something where the server side is setting up a certain state for the app, how do you get it so that then when it gets to the client can pick up where the server is off?
So well, the kind of key bit there is this routing DSL. So in our case, in that demo app, so this is using this sort of custom, well, it's a bit like a CDN on steroids. So you kind of define the resources that you need for a page and the JavaScript template. So that executes the kind of first page, and then once the page loads, JavaScript kind of takes over and makes sure the state is kind of kept in sync with whatever the URL is. I mean, I'm happy to kind of show this afterwards if you want to look at that in more detail. I mean, a more typical kind of approach at the moment would be to use something like, so I think there's something called React Router that's particularly popular for addressing this with Node. Yeah, again, in our case, we're looking for sort of slightly larger scale kind of deployments and faster response times, which is why we've done something bespoke. questions? Okay, thanks.